The Syslog protocol is another method for transporting event messages between our managed devices and systems. This has been around for a long time, and it was standardized in 2009 by RFC 5424. Syslog is widely supported on most major operating systems, including almost all versions of Linux, Unix, Mac OS, and Windows-based systems. In fact, when we looked at the debug command in an earlier lesson, what we're actually seeing are the messages being sent out to our console through Syslog. We've covered NTP, the Network Time Protocol, in an earlier module as well, and we discussed the importance of proper configuration so that all of our devices have their clocks synchronized. If we're using Syslog, it's really important that we have our date and time settings consistent throughout the network. If we don't, then those time-stamped Syslog messages that we use for troubleshooting, they're going to have inaccurate reporting. And that's just going to make our job harder when we're trying to correlate our logs and when we're trying to examine any information about events that have happened on our network. One of the best practices for implementing Syslog is to store our collected log messages on a centralized server. Some of those popular options include Kiwi by SolarWinds, PRTG, and Splunk, just to name a few. The advantage of these centralized tools is that they can gather Syslog records from multiple devices throughout the entire network and provide event correlation. Not only is this correlation process a best practice, but depending on your business, correlation is often mandated. This correlation is one of the foundations for effective log analysis. Different tools will perform this correlation in various ways, but the overall function is that they help to pare down the information that's being presented to us. If we have a really large event in our network, we can have a ton of Syslog messages being generated and sent out to our server. And so event correlation, that's going to help recognize redundant information, and it's going to allow us to sort and view what's happening much more efficiently. Now, one thing that you want to be familiar with regarding Syslog are the message severity levels. By default, there are 8 of those severity levels, numbered 0 through 7. You can see those reflected in this table, along with the corresponding definition for each level. Level 0 Syslog events would be the most critical emergency alerts indicating an unstable system, while at the other end we see Level 7 Syslog events, which are informational debug messages used for troubleshooting. We also have a way to represent which system process created the Syslog event, called Syslog facilities. You can see a list of those available facilities here, and these are all outlined per the RFC 5424 that we mentioned. So all of these facility codes, they can tell us if the message was created, for example, by the mail system. So if we saw facility number 2 in our Syslog, we would know that that was created by the mail system. The RFC standard outlines the 3 different layers found within the Syslog standard, which is the Syslog content, the Syslog application, and the Syslog transport. This standard is necessary so that various devices can create information that can be understood and interpreted widely within our network. The content layer, of course, refers to the information within the Syslog message itself. The Syslog application is what generates and stores the Syslog message, and the Syslog transport layer is used to send the messages over the network, most likely to a centralized Syslog server. If we look at the format of a Syslog message, there are 3 main parts to those messages. We can see the PRI, the header, and the message itself. The PRI, or the priority, that's going to contain the facility and severity codes. The facility code will be listed first, followed by the severity code. So in this example, we see the PRI listed at 100. So that would be a facility code of 10, identifying this as a security message, followed by a critical level 0 emergency indicator. Next, we see the header. And that's composed of 2 main fields. We see the timestamp at which the event was recorded, and we see the host name, with this host name being that of the machine which generated the Syslog message. And the third part are the message contents themselves. This contains the actual information about the event that has occurred. And this can be broken down into two main parts. First is the tag, followed by the content. The tag will contain codes about which particular application and process ID would be related to the event. And the content would, of course, be the actual message output. The output we see here is the Apache server has encountered an error. Syslog services are going to use UDP port 514 for communication by default. So that's an overview of the format of Syslog and why that's useful to us for network management. In our next video, we're going to take a look at how we can configure our Cisco devices for Syslog message generation using both the internal buffer to store those and by pointing those to a central repository for collection.